Here is the hydrogen generator ready to go to Bill. It's running right now. It's at 100 PSI. We filled a 100-pound tank earlier today. Now it's filling a smaller tank. The volt and amp meters reads a little low, but there's some just voltage dropped in the wire. That's normal. Here we have the power switch. To the left is AC, straight up is off. To the right is solar panels. We have the water alarm disable and enable. The buzzer bothers people, so you can turn it off. The buzzer will run when the unit's out of water and it stops running. We can turn our PEM cells in the auto position or off. There is the alarm buzzer and flashing light. Here's the makeup water pump switch in the auto position. It will automatically keep the tank full, pulling from the outside reservoir. On the right side, we have the sight glass showing the water level in the cell. We have a lifting handle. We have the oxygen outlet right here. We never shut the valve. That's just for test purposes. And right now, I've just put the tube in a glass of water, and this represents the oxygen being released. For every oxygen bubble you see here, there are 2 hydrogen bubbles going into the tank. And this will automatically regulate up and down to balance it with whatever hydrogen's there. It's going to keep the same pressure on the oxygen side exactly as what's on the hydrogen side. This prevents a rupture of the PEM and also of the regulator. So however this is, every bubble you see represents 2 hydrogen bubbles. We have the cooling fan right here coming through this side. It's blowing directly on the PEM right now. We'll go around to the left side. We have the left lifting handle. Here the hydrogen comes out here. This is the gauge showing our pressure. We have a check valve there. We have a shut-off valve, and we have the line going to the tanks. For the AC power, we've got a plug-in cord like on a PC, and we got an on-off switch here, and also a fuse is in here, so the AC is fused. The solar panel wires will come through this hole, and then we'll walk around the other side. Okay. So on this side we have the makeup water supply. So with distilled water only. Gravity feeds down into this pump. We couldn't find a pump that would go 200 PSI that was economical and low current draw. So we're actually using a pump that was only designed for 130 PSI. We overrode the pressure switch, and we're able to use this because we bleed off the head pressure so that whenever the pump stops, the excess pressure is bled off. So the next time the pump wants to start up, it's always starting with no head pressure, and it's able to crank up and run at 200 PSI with no problem whatsoever. Pretty cool about that. This tubing here is from the hydrogen water drain. So there's always a little bleed over of water through these PEM cells, and it accumulates on the hydrogen side and has to be bled off and returned. So there's an automatic float, and we'll look at that in a minute. And it will dump back in here to this plastic tank here, right there. And we have the overflow for the tank in case we put too much water in there. And then just beneath this, the hydrogen vent line, we have the hydrogen, a regular 250 PSI relief valve. So if the system pressure goes over 250 PSI, it'll just pop that and release it. The hydrogen vent here, this is for in case of emergency. In case for some reason the hydrogen pressure goes over the oxygen pressure, it will vent the excess hydrogen out and save the system. So that will prevent the rupture of the membrane and the rupture of the regulator. And this is preloaded with a 10-pound spring on the oxygen side. So whatever the oxygen pressure is, it's going to be plus 10. And we have the hydrogen come in on the other side of that, and they work against each other. And so if the hydrogen pressure for any reason gets more than 10 PSI above the oxygen, it will vent it. This can also happen if you start filling a tank that's half full, let's say 100 PSI in it, and you have no pressure in the system, so there's no oxygen pressure. So if that was to happened, you could rupture the diaphragm and the regulator, and also the PEM membrane. So this is the vent for the device, and we'll look at that in a minute. And I just have it sitting in a cup of water so we can monitor if there's any gas being released. And you can see there's no bubbles coming out of it, so it's 100% closed right now. It normally is always closed. It's just in case something goes wrong. It can vent the hydrogen and prevent the system damage. This vent here is just the outlet for the fan on the other side. The air comes in and blows around the PEM cell, and it actually has to go around all of the components and behind the board that you'll see inside, so it covers everything pretty well. Let's go back and look on the inside. Yeah, I heard the water pump just come on. So what we have on the inside, okay, we have the inside of our electrical stuff on the door. Okay, here is the main water tank. And so this is the oxygen water separator. The water level in that can go from anywhere near the bottom to about here. And if it goes above that, it shuts off the pump. It won't let you pump anymore. If it goes below this, it stops the system so you don't run it dry and damage the PEM. Here is the water line coming in, and we have a needle valve on this T, and we have a check valve here and a shut-off valve. And what this does is when the pump starts, it comes through and goes through the check valve, pressurizes the system. Then when it shuts off, we leave this needle valve just cracked open, and so it lets the excess pressure that was in the line slowly bleed back, and it goes around and back into this T and back on the other side back into the tank. So when we energize this thing, well, first of all, the water is being gravity fed down to the bottom, and we have over 10 inches of drop and a pretty straight run. When we apply electricity to this, the hydrogen's formed on one side and oxygen with the water on this same side. So the oxygen and the water will come up this one, and it's with the bubbles in there, it's like a percolator, and that causes the water to circulate through the tank of the system. This is the hydrogen line, so the hydrogen gas comes out here. This is the pressure switch that turns the system on and off at 200 PSI. And this is the gauge for the hydrogen, and the hydrogen and the water bleed over. It comes into this tank here. Take that off now. And in this tank, it has a float, a stainless steel float, and it's in the side of a carbon fiber housing that I built, and it has a toggle cam action. Because the float only has a buoyancy of 0.2 pounds, it takes mathematically, it takes 5.7 pounds to open the valve on the bottom of this to drain that water. So I come up with a device, a toggle link with a cam that amplifies the force of the float by 50 times. So we only need 27 times to open the valve, but so we built it for 50 for insurance. And when that float rises, well, you'll see the water go back into the system on the other side. Over here we have a solar panel, MPPT voltage regulator. We have the oxygen pressure in the system. This pressure switch we're using to shut off the pump. If it exceeds 200 psi, the water pump won't run. That's to prevent any damage. As the oxygen comes out of this side, it comes down in here. It makes a stop over here in this relief valve. We built this to relieve any excess hydrogen pressure, and I'll go back into that in a minute. But the hydrogen that's being output is going through this line into the dual passive modulating regulator, and you'll see there's two sides on that. In the middle there's a rubber diaphragm, and there's a valve stem on each side of that rubber diaphragm that will stick into the port on either the hydrogen side on the left or the oxygen side on the right. As pressures change, the diaphragm with the valve stems move from the high pressure side to the low pressure side, starts throttling off the low pressure side until it builds, and it can even shut it off completely until that pressure builds enough to equal the pressure on the other side. So this thing's working back and forth constantly, trying to keep both sides at the same pressure. Since we're not keeping the oxygen, we only hold back what we need to keep the pressure balanced. Excess oxygen is released, goes through this tube and out the side. But with the hydrogen side, it's a little different, as we're sending everything to the tank. If we get in a situation where we start with a tank that's half full, let's say, and we don't have any oxygen pressure on the side, that would tear the diaphragm and the regulator, and it would and the PEM. So what we did here to alleviate that is to also run the oxygen into this regulator here. Kind of the same principle as the other one, but there's no outlet for the oxygen. The oxygen just comes in and out the same one. And this one is the hydrogen in here, and we preload this side. Now there's the water pump refilling here. We preload the oxygen side with a 10-pound spring, so it's whatever the oxygen pressure is plus 10 pounds is the force we have holding the hydrogen valve outlet closed. If the hydrogen gets more than 10 pounds higher than the oxygen side, it will start pressing the diaphragm away from the hydrogen, and it starts to open the valve and will release the hydrogen out the back in the vent. And that's a really big saver and safety and that heavy thing, especially if we had an oxygen blowout. It would PEM and membrane would all be damaged, but this regulator will prevent that from being damaged, so they can't tear. This is saves it to 100%. We have an AC power supply that's 20 amps, and it's a variable supply, 0 to 24 volts. Right now we have the 600 milliliter PEM cell in right here, and so it runs at 10 volts and 20 amps. Those cells like to pull the voltage down to whatever they want it to be, so right now it's pulling it down to 8.35. And over here, these red lights at 27, that's 27 degrees Celsius. That's a digital thermometer, temperature controller. We have a thermocouple up top here, measuring the temperature, and it starts up this fan right here. This fan is running right now. As you see, it blows on the tubing and on the PEM. It has to go around everything and slide around the back of the panel to the vent out there. So that keeps any leaking hydrogen purged out and keeps it cool. We have the control bus here. This is just 12 volt DC for all the relays and controls. We have a voltage regulator here where we're taking, it's a buck boost regulator. So wherever power we have coming in, if we have the AC coming in or the solar power, whatever that voltage is, it's going to change it to 12 volt DC for all the controls, and that's what that bus is there. In the back of the switch here, when you switch it to AC or solar panel, it will take that incoming power and direct it back to that regulator and to the PEM cells. This relay right here, this power relay, is to run the PEM, and these other three plug-in relays are identical, and their function is to monitor the float valves and other pressure switches, and turns the pumps on and off, and also controls the PEM and everything we got going on. We have a fuse bus in the back here. Everything is fused, properly fused. Terminal strip down the bottom for what's going to the door and other things. The hydrogen tank here, as the hydrogen comes in, of course, the water drops out, and then we have the stainless steel float inside, and the carbon fiber reinforced polycarbonate housing that has the toggle cam link and amplifies the float by 50 pounds, and then lets the water out the bottom. This is where the AC comes in, all those blue connectors, and everything's coated. So everything that's 110 volt AC is insulated, so you don't have to worry about putting your hand in here and getting a shock, but you can just shut that switch off from the outside to be safe and unplug it if you wish. We have a ground bus here, and we have grounding wire going to the PEM and also the power supply. So all the plumbing, the panel, the cabinet, everything is all grounded. And that looks about it. I think that's about everything. So right now it's working perfect. We topped off a 100-pound tank today, and now we're filling another tank. I've been dumping or burning off all the gas I have in the tanks because I need a place to put more gas, because we're making a whole lot more gas than I have places to put it. So we've just been dumping it or burning it or disposing of it, and everything's running perfect. You'll hear this pump come on every once in a while when it refills that tank, because as that tank, as that water gets used up, more water will get bleed through than is being converted to hydrogen and oxygen. So it is a decent flow anyway. And you really have to have that automatic drain and a pump to bring it back. Otherwise, you'll be turning it off and draining it manually constantly. So this is fully automated. This is once you turn it on, it's hands off. It's going to run. We get the conversion of 1,240 times the water. So thing holds about 4 liters of water in all. So it can make almost 5,000 liters of gas with the water that's in it. So let's go in the bill now. We're going to pack it up and take it to them in 2 days, and we'll see what goes from there.